Hello, good morning students. We are discussing about the Gauss theorem. Okay, we have seen the proof of Gauss theorem. Then today we have to discuss about the applications depending on the Gauss theorem. Okay, so some MCQs are on the whiteboards and we have to solve today, means how we can apply here Gauss law in a particular MCQs. Now see here, first MCQ and second MCQ, two MCQs are here, and in that MCQs we have to apply Gauss law, or we can say Gauss theorem. Now in first application, or we can say in first MCQ, which things are given to us, let us discuss. A uniform electric field of magnitude, so this one is the electric field intensity E. So we have to write which things are given to us, that is electric field E is equal to 100 Newton per Coulomb. Okay, exists in the space in x direction, so it is given in x direction. Calculate the flux of this field through a plane. We have to calculate here flux, that is the electric flux passing through the unit area. So to find out flux, we must know it is related to the Gauss law, or we can say Gauss theorem, of this field through a plane surface area of edge 10 centimeter. See here, edge is given 10 centimeter. Here the meaning of edge is side, so a side is given, it is 10 centimeter. So we can write this 10 centimeter like this, so 10 into 10 to the power minus 2 meter. So which plane is given? So this 10 centimeter edge, it is placed in YZ plane, so we have to place that edge in YZ plane, and again consider the normal along the positive x-axis to be positive. So here consider a plate in YZ direction. So here we consider this one is the YZ plane. So it is a plane surface area. Plane surface area, that is means what? It is a square plate. So we can put this one like this. So each side is 10 centimeter, so another side should be 10 centimeter. Now see, we have to find electric flux, and electric flux is away from the positive charge. So we can solve this problem using Gauss law. So we can write using Gauss law. Gauss law is electric flux is equal to close integral E ds cos theta. Okay, so area vector and the direction of electric flux, they are in the same direction, so that's why we consider theta is equal to 0, and if theta is equal to 0, then cos 0 is equal to 1. How we can solve it? So we can take out this E, electric field intensity, integration of ds, and cos theta, that is 0, it is exactly 1. So here we get E integration of ds, that is for electric flux. Now Integration of ds means what? Area of plate. Okay, area of square plate. So area of square plate. So but integration of ds stands for what? Area of square plate. So area of square plate. And what is area of square plate? How we can find out the area of square? That is side square, obviously. So side is given, one side is given, that is 10 centimeter. So another side also 10 centimeter. So how we can calculate area? So therefore integration of ds means what? The area of square plate, and area of square plate is side square. Side is, that is 10 centi. Centi means what? Minus 2. 10 centi, side square, it is square. So we get here 100 into 10 to the power minus 4. Okay, so this is the integration of ds. Now our formula to calculate electric flux, that is phi E, is exactly equal to electric intensity E into integration of ds. Integration of ds. So what is electric field intensity? It is given, electric field intensity is 100 Newton per Coulomb. So we can write here 100 into area of ds. Area of ds means what? That is integration of ds means what? Area of square plate. So area of square plate, and we know area of square plate, that is side square. And what is the area? That is 4 into 100 into 10 to the power minus 4 into 100 into 10 to the power minus 4. How we can calculate? That is 100 into 100, that is 10 to the power 4 into 10 to the power minus 4. So 10 to the power plus 4 and 10 to the power minus 4, it becomes, both are cancelled. So we can write, what we can write? That is remaining term is there only 1. So 1, this is the electric flux. So electric flux passing through unit area. And how we can measure the electric flux? Newton meter square per Coulomb. So Newton meter square per Coulomb. So this is the unit to find electric flux. Electric flux. Okay. So in this way we can easily solve the problems depending on Gauss theorem, or we can say Gauss law. So these are the very simple, but one thing is I want to tell you, that is you should remember Gauss law. Gauss law is nothing but just, it is a number of electric flux passing through unit area is exactly is equal to enclosed charge divided by epsilon naught. Okay, or we can say simple, we can write that is integration of EDS cos theta. Now see, this one is the concept of electric flux. Now in second problem, which things are given to us? So firstly we discuss a large plane charge sheet. So here a large plane sheet is given. Okay, and we have seen if large infinite plane sheet is given, then how we can find out the electric field intensity of that plane sheet. Okay, we have seen already discussed in Gauss theorem, that is the applications of Gauss theorem. One is related to the sphere and another is related to the what? Infinite plane sheet. Okay, so already we calculate there, if a infinite plane sheet is given, then how we can find out the electric field intensity of that particular plane sheet. So see here, consider then the surface charge density. Surface charge density, it is represented by sigma, and the value of sigma is given, that is 2 into 10 to the power minus 6, lies in the xy plane. Find the flux of electric field through a circular area of radius 1 centimeter lying completely. So radius is given, it is 1 centimeter. So which things are given to here? that is sigma is given, sigma is 2 into 10 to the power minus 6 coulomb per meter square. Then radius is given, that is 1 centi, and centi means what? 10 to the power minus 2 meter. Lying completely in the region where x, y, z are positive and with the normal making an angle making of 60 degree with the z axis. Means here a large plane sheet is having surface charge density lies in the xy plane. So here if we consider this one is the xy plane, suppose xy plane, this one is the y axis. So here if we consider a large plane, okay, charge sheet, and here a circle is, find the flux electric through the electric field through the circular area. Now if the circle is here, but while placing that circle, then the angle inclination must be 60 degree with z axis. So here we have to place a circle in this way, it makes angle 60 degree with z axis. So this one is the z axis. So we have to put whether in this, at this place, so that angle must be make theta which is equal to 60 degree. Okay, so this one is the condition. So we can apply electric flux. So firstly what we have to calculate, that is find the flux of electric field. Flux, find the flux. Flux means what? Electric flux passing through unit area. So electric flux, if we want to find out, then we know the electric field intensity in this case, that is in this case electric field intensity is E is equal to sigma into 2 into epsilon naught. So this is the derivation which we have seen. If a plane sheet is there, infinite plane sheet is there, and if we want to find out the electric field intensity, then the electric field intensity can be calculated by using this formula, that is E is equal to sigma upon 2 epsilon naught. So this concept may be used only for if large plane sheet is there. Okay, so you should be memorized, if large plane sheet is there, then you should use this E is equal to sigma upon 2 pi sigma upon 2 epsilon naught. Now see, to find the flux, that is flux, how we can calculate the electric flux here. So to calculate electric flux, same concept we can apply here. The concept is, that is electric flux, that is electric flux is equal to integration of E ds cos theta. So here E, integration of ds and cos theta. What is theta? So theta is given here 60 degree, and we know cos 60. So what is the value of cos 60? But cos 60 is equal to 1 by 2. So therefore electric flux can be written as, that is E into integration of ds into 1 by 2. So therefore we can write E by 2, E multiplied by 1 by 2, E by 2 into integration of ds. So this is what? This is for electric flux. So electric flux is equal to E by 2 into integration of ds. And what is integration of ds? So integration of ds means what? That is the area of cross sectional. So area of cross section area, but cross sectional area, what is the value of cross sectional area, or formula for cross sectional area? Pi r square. So we can put, that is electric flux is equal to E by 2 into integration of ds, that is integration of unit area, that is pi r square into pi r square. Now we can easily put the formula which is used for large plane sheet. So what is the electric field intensity for large plane sheet? It is E is equal to sigma upon 2 pi 2 epsilon naught. So instead of this E, we have to use, that is, electric flux is equal to, so instead of E, what is formula of E? Sigma upon 2 epsilon naught. So we can write sigma upon 2 epsilon naught, and already 2 is here, so already 2 is there, into pi r square. So electric flux will be sigma upon 4 epsilon naught into pi r square. Now we can substitute all the values, because we know epsilon naught, it has constant value, and you must know that constant value, because you have to put here. And sigma is given. What is sigma? Sigma stands for what? Sigma, it is a surface charge density. This surface charge density, that is sigma, and the value of sigma is given 2 into 10 to the power minus 6. So here 2 into 10 to the power minus 6, so the value of sigma is given here. So that's why we can put here, that is electric flux is equal to 2 into 10 to the power minus 6 upon 4 into, what is epsilon naught? It is 8.85 into 10 to the power minus 12 into 3.14 r is given. Where is r? The radius is given, it is 1 centimeter. So therefore we can write, that is radius 1 centi means what? 10 to the power minus 2 bracket square, that is whole square. Okay, so there are 2 to get cancelled, then remaining term is electric flux is equal to 10 to the power minus 6 upon 8.85 into 10 to the power minus 12 multiplied by 3.14 multiplied by 10 to the power minus 4. So we have to calculate here flux, that is how many electric lines of force passing through that particular unit area. So here electric flux will be, if you calculate this term, so this terms will be 17.5 Newton meter per square per coulomb. So 17.5, that is the final answer, Newton meter square per coulomb. So this is the proper method to find out electric flux. So see here, electric flux and Coulomb's law. So these are the very most important topic from electrostat unit, electric flux and Gauss law, because most of the applications or most of the MCQs depends on that articles, and it may be asked in your exams, calculate the electric flux, or we can say Gauss theorem. Okay, so I think you will understand these applications depending on the flux and Gauss theorem. Okay, so in our next period we will discuss about the same concept and same problems. Okay, so till then, goodbye, thank you.